Hey guys, I'm Soumya Agrawal from IIPS DAVV, and in this first tutorial, I'll be explaining you about bisection method. Its definition is: the bisection method in mathematics is a root finding method that repeatedly bisects an interval and then selects a subinterval in which a root must lie for further processing. Now, using this graph, we can understand the bisection method. We have a graph y is equals to f of x. Let its curve be like something like this. We took 2 points, a1 and b1. Now we find values of a1 and b1 on the graph, that is f of b1 and f of a1. Now this becomes our interval, and we took this interval as so that we can find the root between it. If the root doesn't lie between this interval, then we have to again enter another range, that is a1 and a2, with new values so that we can have the root within that range. Now the basic concept in bisection method is we will find the values of a1 and b1 on the graph, that is f of a1 and f of b1. Then after that we will find the midpoint, that is mean of a1 and b1, that is a1 plus b1 by 2. Let's say if it comes out to be a2, then we have to judge that we in which direction we have to shift the interval, that is from either a1 to a2 or b1 to a2, so that the root comes closer to the interval. Now as f of a1 and f of a2 are on same side of the graph, that is on the positive side, then this means that the value of a1 now new value of a1 is now equals to a2. But if in case the value of a1 plus b1 by 2 becomes b2, it comes out to be b2, then this means that f of b1 and f of b2 are on the same side. So in that case we are going to shift b1 to this point, that is now new value of b1 is equals to b2. Let us now understand the flowchart of bisection method. As soon as the program starts, it will prompt us to enter a and b, that is the range in which we are willing to find our roots. Then the next step is to check whether a and b that we have entered are correct or not. As f of a into f of b, if the root lies in the a and b, then the curve will have changed its sign, that is from positive to negative or either from negative to positive. It depends on how the curve is actually formed. So we will check that f of a into f of b is greater than 0. This will show us that either a and b lies on the same side or the different side. For example, here f of a into f of b results into negative. This means that a and b are on different sides of the root, that is one on the left and the other on the right. But if it comes out to be positive, that is f of a into f of b comes out to be positive, then it means that a and b are either on the left side of the root, that is a1 lies here and b1 also lies here, or either a1 lies here and b1 lies here, that is both a and b are on the left side or on the right side of the root. Now if f of a into f of b greater than 0, that is if they both lie on the same side compared to root, then we have to print that the program will print that it is the invalid interval and we are not going to find a root in this particular interval. So we have to again enter a new interval. But if not, that is if f of a and f of b is less than 0, that is a and b lies on the different side, that is one on the left and one on the right, then we have to find the value of m, that is a plus b by 2. Here I is acting as a counter. Now we have to find f of m. If f of m equals to 0, then it means that m is the root of equation. If yes, then m is root and we have to stop the program. But if not, then we will find f of a into f of m, because if m is not the root, that is if m is not the red point, then it means that the value we obtained as m lies either on the left side of the original root or on the right side of the original root. So if it lies on the left side of the original root, as we can see in this case, then we have to shift our a to right, and if the new value of m lies on the right side of the root, then we have to shift b to the point, so that the range will decrease and we will get closer to our root. And by continuing this process, we will get closer and closer to our root. Now we will look about the program that we are aimed to create, program for bisection method using R language. Now for writing a program in R language, I am using R Studio. Here we'll write the code, source code. Here we will observe our output, and here the files that we have created will come in these folders. I've created my files in the folder name R. I have certain files like array, bisection, function, Lagrangian, etc. We are going to see about the bisection program. Now let's take a look. I'm going to find the roots of equation x square minus x minus 1. So I've created a function. In R we create a function as, we'll give a name to the function. I've given the name of function as func, and it is declared as function which is going to take one input, one parameter as x, and it's going to return the value of x square minus x minus 1. That is the desired value when we put x into that function. Now we are entering two values of a and b. A, read line prompt, enter a. Now as integer we are converting these values into integer. Now if function a into function b, now we are checking here that whether the interval we have entered is correct or not. If it is greater than 0, then the system will print invalid interval. But if not, then we will find the midpoint, then we will increase the counter, and we will check the value of m until the desired value, that is acceptable error value range, is satisfied. Now we'll first print the iteration number, that in which iteration we are working. Then there's some certain printing statement which is going to print the values of a, b, m, and f of m, that is function m. I've taken f of a, that is function a, and function m in variables fa and fm. Now if f of a into f of m, that is fa into f of m, is greater than 0, then the a will shift towards the root, otherwise b will move towards the root, as we can see here. We've also understood this back in the graph, that when to change a and when to change b. Now here we will again change the value of m to a plus b by 2, and then print the value and increase the counter. And again here is the printing statement which is going to print I, a, b, m, function m, and root at the end of program. Now to run this program, we will click on the button source. Now here we can see that the file bisection is running. Now we will enter here, let's say 3 and 5. This interval is invalid because none of the roots of equation x square minus x minus 1 lies within 3 and 5. So now again I'll run this file bisection. We can see here that the bisection is written. Now if we enter 1 and 2, now we will get the answer as 1.6180, which is the actual root of equation x square minus x minus 1, and we are obtaining this in iteration number 17, and these are the results which we can observe: the first iteration, the second iteration, the third iteration, and the roots, that is I, a, b, m, and f of m. This is a, b, m, f of m, and so on like this, and at the end we will observe that the root is 1.6180. So this is how we find root of an equation using bisection method.